All right, everyone, let's talk about our in-class midterm for Wednesday and Thursday, October 11th or 12th. So the first thing that you're going to want to make sure to do is to bring the right instruments. So one thing you're going to need is to bring a calculator that's going to be able to do exponents and logarithms. Now this can't be on your phone. It can be any other standard calculator. You're just not going to be using your laptops or your phones at all during the exam. So whatever other calculator you want to bring is totally fine by me. Now, the other thing that you're going to want to bring in is a sheet of notes. Now, this sheet of notes needs to be handwritten. That policy might be a bit different than when you took BAS 320. It needs to be physically written by you, and it needs to fit on a standard size piece of paper, the 11 by 8s. Front and back is okay, but the exam, like most of my exams, are designed to be on a bit of the long side. You're not going to have a lot of time to really search through exactly where you wrote a particular thing. So you're going to want to try to keep those notes as brief as possible, but you're allowed to write as much as you want. All right, so what kind of things should you expect on the exam? Well, all of my exams are always a mix of kind of numerical calculations, a bit of short answer, maybe some true and false multiple choice, and maybe a more involved kind of fourth page question that you'll be just kind of writing an essay for. So you'll see that here. We'll have a few mathematical calculations like calculating the probability of something, a few short answers, talking about like, all right, what does the lift of 2.5 actually mean? And there's going to be a section on reading code, which is essentially short answers, basically saying, all right, what does this code do? Or what's wrong with this code? Stuff that you will have picked up as you've been working through the activities and the homeworks. So what's the best way to study? Well, looking over the problems that you guys have already been assigned is always my first recommendation. There's a lot of notes that I produce for this class. It kind of serves as a textbook. And there's only a small part of those notes that really get emphasized when it comes to exam time or just asking you questions. And so the solutions to the activities and the solutions to the homeworks are going to be a good guide for things to study that you're going to make sure to have down when it comes exam time. So review those solutions to the activities, specifically the one that we just did about logistic regression and classification. That covers a lot of really important content, and you should be pretty good to go. I have put together an updated set of review slides, and I'll talk about those briefly, that kind of hits on what the major topics are, and the vast majority of the topics covered on the exam are going to be covered in some detail on the review slides. But even then, not every review slide is going to be something that there's going to be a question about, so there's still more important slides than others. Also, what I've done is I've posted last year's exam, which I'll talk about in a second as well, to give you a better idea over what types of questions you're likely to see on your midterm. Now, the questions aren't going to be verbatim or anything, but it gives you an idea of the level of difficulty and the types of things that I expect you to know. The only problem with this last year's exam is it has a lot of additional material that we haven't gotten to yet. The last year's midterm occurred later in the year, and so there's going to be a lot of questions you'll look at and you'll wonder, wait, did we learn this? No, you haven't. We'll get to that stuff, but that gives you a good idea of what the level of difficulty and everything that I tend to ask. Now, one thing that I do want to mention is the updated review slides and updated slides for the logistic regression. One thing that I had failed to correct when I went through my last iteration was the labeling of the true positive, false negative, true negative, etc. in the confusion matrix. Now, it's all fixed for the lecture notes and for the review slides now, but if you downloaded it previously, it wouldn't be fixed, and so you could get confused because, all right, why are there two different sets of slides saying two different things? So what I've done is I've put here basically what these slides should be reading in terms of breaking down what a confusion matrix looks like, the columns representing the actual classes that the individuals had in the data, the rows labeling what the individuals had according to the model that's being used to predict them, and then what the true positives, true negatives, false positives, and false negatives are. Because you will be given a confusion matrix on the exam, and you'll be calculating at least two of these numbers: false positive rate, false negative rate, accuracy, misclassification rate, etc. So you want to make sure to have probably this little bit in your handwritten notes so that you have that as a handy reference. All right, so let's talk a little bit about more of the questions here. And I think what I want to do first is to reference last semester's exam. And the first thing I want to talk about is what to expect about me testing you about R. So you just did the take-home midterm. You spent a large number of hours working through some really good questions to put your knowledge of R to the test here. So what kind of additional things am I likely to ask? Well, we spent a lot of time learning how to read code and learn kind of how to figure out what it's doing in English. We've learned how to debug code in efficient manners, etc. And so this isn't something that you're really going to have too much success studying for. It's kind of stuff that you should know by now. And so let me just kind of break down what some of the questions were that I asked last time and could be fairly similar to questions that I would ask, say, this time around. So the first question here, when I was asking about code, was to give a bunch of lines that were to define a function, and then just to quiz you, all right, what's going to happen if I were to put in specific arguments to these functions? Which ones would end up working, which lines wouldn't work, and when they did work, all right, what is the function going to return? And so I just ask, all right, well, what's going to happen? So expect to see something very similar where I've written a function and I essentially say, all right, well, what's the function going to output if I put in this set of arguments? What's the function going to equal if I put in this set of arguments? What's the value of this variable after the function is run, etc. So reviewing some of those notes about functions could be useful, but by now you should know approximately kind of what happens when a function runs, that you really shouldn't have to do too much studying. So the second question here, part B, was asking a bit about the which command. I guarantee you all have something about the which command on the exam, so making sure you know how the which command works. Which allows you to identify where inside of a vector the element numbers, the first element, the ninth element, etc., which elements have a certain logical condition holding true or false is what which is really useful for here. So asking like which letters equal C is saying, all right, which position inside the letters vector has an element that is equal to C character. So we have double quotes here. So this is asking you to do some debugging actually, and I'll ask you to do some debugging too. I have a great slide that says, all right, here are 2 or 3 of the most common errors that people have made. I guarantee that you've made each one of the errors so far and you've learned from your mistakes, so this is why you probably don't really need to study. You kind of know what to look for at this point. And so here's a bunch of code that's supposed to accomplish something, but it doesn't. The output at the end of running the code is a bunch of NAs and the number 19, and I say what the code should have outputted, the number 16, 1, 19, 19, and it's up to you to figure out, well, what went wrong. And so expect to see something fairly similar, where in this case the error isn't necessarily with the which command, it was in how the for loop was constructed. So knowing that, all right, in the parentheses, for a for loop here, we always have that word in. We have something to the left of in, we have something to the right of in. Knowing what purposes those two objects hold is very important, understanding when a for loop is going to work and when it's not going to work. So you can look at this and you can identify where the code went wrong. I'm not going to give you the answer for this one. Likewise, for the third question, it's asking you to do some debugging as well. So here's this great looking function that's supposed to either return true or false if, or actually let me read it here. It's supposed to produce all even numbers inside the argument here, x, that are x are less here. So basically, all right, if we apply this function to the number 10, we would have expected to have produced, say, the numbers 0, 2, 4, 6, 8, 10, the ones that are at most 10 here, 10 or less, but this function actually returns nothing whatsoever. So what's the problem? Where's the breakdown in the code? So you can look at it, stare at it a while, figure out, all right, what's the issue? These are the types of questions I'm going to be asking you about. So here's a great command that says, all right, what's going to happen when I run this which command here, testing your knowledge about square brackets and the which command. Here's a question about checking to see, all right, well, is an element of x NA? Is it missing or is it present? Here's a question about logical conditions, and here's a question about the subset command. So stuff that you've done really quite a bit, and so hopefully you shouldn't have too much of a problem identifying where issues are inside the code. So the first kind of big set of notes in the midterm review are just talking about some of the major commands that we've used and tasks that you should be pretty familiar with. So removing elements of vectors, referring to elements of a vector with the square brackets, with the minus sign, etc. You know how to do this by now. Being a pro at the which command is definitely something I suggest that you be coming into the exam. And of course, in order to be a master of the which command, you need to know all about logical conditions. How do you check to see if an element is equal to something, not equal to something, less than something? Is that element NA? Or is it present, not NA, the exclamation point in front of the is.NA here. Combining conditions with the ampersand or the pipe symbol, and also things to know about, along of course with the percentage in shortcut, why it is a shortcut, why we could just write this with a whole bunch of pipe symbols here, kind of all good stuff for you to know. So that's kind of the purpose of what the review notes are here for R. Just kind of giving you the basics of what the commands do, a brief review, but you should know pretty much all you need to know about this stuff by now. So once again, the for loop, once again, it's really just a shortcut here for a whole bunch of lines of code. So kind of understanding how the for loop works, how you can read a for loop and kind of say in English what that for loop is trying to accomplish, pretty important. Being able to take a for loop and being able to reproduce the sequence of lines of code that essentially got run as the for loop was executed, also another really important skill. So something you can work on here. What else do you need to know about, well, for loops? Well, that's about it. The common errors are things, of course, to focus in on when you're doing the debugging. So remember those 3 common errors here, kind of illustrations of them when they crop up and, how they would end up being fixed. A bit about if-then statements, stuff that you guys should know by now. So as you're pretty much hearing again and again, it's stuff that's hard to just study about because it's stuff that you've run into quite a bit so far. So as long as you've been, up to date on your activities and your homework and you've got a lot of practice doing R coding, this should be, second nature. All right, a little bit about functions. You should know how a function works. Basically, remember we had that, what happens inside of a function stays inside of a function, where basically things that are defined cease to exist once that function is terminated, because the calling of a function basically creates that mini universe where everything that is inside of a function, all those lines of code, is actually run. So knowing a little bit about how a function works, what a function can and can't do, also some good stuff. So not much more to say about that, so you can read over some of the things that I expect you to know, but definitely not stuff to memorize necessarily. Now, one thing you weren't asked about in the take-home midterm was stuff about missing data patterns. And this is where I'm going to actually put some stuff on the exam. So we use the mice package to look at missing data patterns with that MD pattern. And you're going to want to be familiar with how you interpret a table that looks like this. So remember, the way that we interpret it is that this very far left number is telling us how many times we see a particular pattern. The ones and the zeros inside the block of numbers here tell us whether or not the particular values of the variable were present, that's a 1, or missing, that's a 0. So for instance, there are 35 rows where solar radiation was present, but ozone was missing. There's 111 instances where both values were present. The number on the very far right is telling you the number of missing values associated with that missing value pattern. This one has 2 missing values, this one has 1 missing value, etc. Being able to read that is definitely something that you'll be expected to do on the exam. I'm not going to test too much about patterns to look for here. We didn't really cover this in class in all that much detail, and I never asked you a homework question about it, so don't worry too much about this slide here. One thing that we did talk about, though, is determining whether or not patterns were statistically significant, and basically what different rules for missingness look like. So we used this a priori package, we ran some code, and we came up with output that looked like this, basically a list of rules that told us something about patterns in missingness. And this is something that I'm going to hold you responsible for on the in-class midterm here. So we've talked about how to take a rule and to translate that into English. So basically what we know is that we look at the arrow sign here, we look to what's to the left, we look what's to the right, and then we interpret this just in English. Basically, if the value in solar radiation is missing, then ozone is also missing. We have some numbers associated with this rule. The confidence tells us the probability that that other value is missing as well. So if solar radiation is missing, then ozone is missing with a 29% chance. So it's a good interpretation of that word confidence, but the key skill is basically translating what that rule means just in English. If solar radiation is missing, then ozone is also missing. If ozone is missing, then solar radiation is also missing. One thing that you did spend a bit of time, though, talking about is how to interpret this value here called the lift. And if you remember what the lift tells you, is it's something about how often those values are missing together compared to what you would expect just by chance alone. So be prepared to interpret the value of a lift, much like what you did on the activity and on the homework. I'm going to put that on the test. The last thing we talked about was whether or not those patterns really were or were not statistically significant. So just from natural sampling variation, the sheer process of collecting data, all right, we're going to find these two variables missing together, some amount. And whether or not a rule is statistically significant or not tells us whether or not we would have expected those two variables to have been missing together as often as what we've observed just by chance alone. So if you remember, when we interpret the value of the lift, it's basically telling us how many times more often we see those values missing together than chance alone would dictate. It looks like ozone and solar radiation are missing together about 1.18 times more frequently than chance alone would expect. That's a little bit more often. Is that really indicative of a pattern? Is that rule statistically significant? That's when we looked at these two numbers here in the interest measures output. If this was less than 0.05, then we'd say that yes, that rule is statistically significant. We actually get trues and falses here that tell us that as well. And basically, that was our rule. If this number was less than 0.05, or this value here was true, then the rules were statistically significant, indicating that if we knew one of the values was missing, that actually does give us information about whether or not the other value is missing as well. So be familiar with interpreting those missing value rules here. That's something I'm going to expect you to do on the exam. All right, so you can refer back to the homework solutions, the activity solutions, some stuff here as well. I'll give a pretty good idea of what you're going to be tested on. All right, last thing that I should bring to your attention about, how do you study for, an exam that's covering, say, stuff about R, stuff that we did in R, is this last section that we didn't explicitly go over in class, but it's definitely extremely useful now because we've learned everything there is to know about R programming. So how R processes commands, basically if you have a really complex command, how does R actually go and figure out what to do? So we've talked about, order of operations, multiplication, division before addition, subtraction. We've talked about parentheses so that certain operations occur first. Now is a really good time to figure out, all right, how do these more complex expressions actually get evaluated? So at this point, I don't think I'm going to put a question like this on the exam, but I might change my mind here. So if I were to say, all right, if I were to shoot R, this expression right here, what's going to be the very first thing that R is actually going to evaluate? So 5 plus 2 times the square root of log 10 of 92 plus the absolute value of 2 minus 8. All of that, outside of the square root at least, raised to the 4th power. So which operation actually occurs first inside when R is actually performing it? Well, we know that R goes as deep as it can inside the curly brackets or square brackets or parentheses to figure out what to evaluate first. And in this case, the deepest inside the command it can go is actually this 2 minus 10. So the first thing that will happen is that 2 minus 10 is evaluated first. That's minus 8. Then the absolute value sign is going to be applied to that to get positive 8. Then, as deep as we can go is what's inside the parentheses here, this 92 plus positive 8 at this point, 100. The log base 10 of that is going to be 2. The square root of that is going to be just the square root of 2, but then when we raise that to the 4th power, that'll be the square root of 2 raised to the 4th power, which is 4, maybe, times 2, that should be 8, and then add 5 to it, that'll be 13. So a lot more complex than what I would ask you on the exam, but knowing that we basically dive as deep as we can into parentheses and square brackets, good stuff to know. Okay, so that's about all I have to say about the notes addressing the how to think like R and R programming parts. Most of that was already tested on the out of class portion. So a lot of these slides are pretty much here just for an overall review. You're not held to responsible for a lot of them. I've pointed out the ones that I want you to focus in on. All right, we just turned to data mining, a couple weeks ago, and we started out with classification. So you've only done one homework and one activity on this stuff, so there obviously can't be too much that I'm going to ask about it, but I'm definitely going to do my best to try. The majority of the exam is going to be focused in on doing predictive analytics, this classification, major concepts in classification, and how we use logistic regression for it. So I did mention that you're going to want to bring that calculator because you will be doing some computations. What computations must you be able to do? Well, one thing you'll be able to need to do is look at a confusion matrix and calculate the prior probabilities of each of the two classes that we might be predicting. Remember that naive model goes and just assigns everyone to be the majority class. And so figuring out which proportion of the yes class exists in the data, the no class exists in the data, is an important skill to have. It's easy. You just count up the number of that class, divide by the number of individuals in the data. But you need to be able to do that. And you need to be able to do that from the confusion matrix. Also, like what you've done on the activities and on the homeworks, is to calculate the probability of each class from a logistic regression model. What's a question like that going to look like? Well, you might see something like this. You have a bit of output from R that says, all right, the output of a logistic regression gave this. Here are the coefficients of the predictor variables and the intercept here. Well, go ahead, refer back to the equation for the logistic regression model and figure out what the probability is of each of the two classes. So you've done this on the activity, you've done this on the homework, it's nothing new, but this is one of the reasons you'll need your calculator, because you know that the model lurking behind a logistic regression is a nonlinear equation, and so you're going to have to be able to take E and raise that to some particular power. So you'll have to take E, raise that to the intercept, plus that first coefficient times the value of the first variable, etc., all the way down the line. Make sure you get your parentheses right. Make sure that it gets evaluated to the correct number. Also, along with that confusion matrix, where you'll be calculating, say, prior probabilities, is the expectation that you'll be able to calculate the misclassification rate, the accuracy, the false positive rate, and false negative rate from a confusion matrix. So something very similar to what I had asked the last time around. I gave everyone a confusion matrix and said, all right, let's calculate some things. So be prepared to answer questions like this based on the appearance of a confusion matrix. Now, I've swapped rows and columns this semester to be consistent with the carrot package. So don't be too overly reliant on what this confusion matrix looks like. But given a confusion matrix, make sure you can calculate these three quantities here. Also be able to calculate the accuracy, the misclassification rate of the naive model that goes with the prior probabilities of each of those classes, and you should be good to go. All right, so that's what you'll be using your calculator for. What else do you need to know about data mining for this exam? All right, well, a bunch of concepts here. So we've talked about a few modeling concepts: logistic regression, the naive model, the guessing at random model. And you should know, all right, how do each of these three models approach, making classifications here. So a very good slide. Make sure you're going to be able to know the answers to all of these questions right here. How does the naive model make classifications? How does the guessing at random model do so? Basically, majority rules, basically flips a coin, and the probability of each class is proportional to how often each of those classes are appearing in the data. Logistic regression, when can we use it? When can't we use it? Well, we had some slides that went over that. Basically, if we expect the probability to be strictly increasing or strictly decreasing as the values of our predictor variables get bigger or smaller, then we're definitely good to go. Go back through the notes about logistic regression to know when it's okay to use a logistic regression model. I guarantee you I'm asking a question about this, and it's a really good question. So you're going to want to know, when is it okay to use a logistic regression, just based on the description of a problem here. All right, so also you're going to want to know a lot about model evaluation. So back in this exam from last semester, I started out by saying, all right, how do we actually evaluate models? Well, we want our model to make the smallest error as possible, so we talk about the generalization error of a classification model. How do we estimate that? How do we calculate that? Well, it all comes down to the confusion matrix and what we're using to actually gauge the quality of the model, the misclassification rate, the false positive rate, etc. But basically, how do we actually go about estimating that stuff, when we're building a model? So we talked a lot about k-fold cross-validation, repeated k-fold cross-validation. Know the ins and outs of how this works. I'm not going to ask this question exactly, but I'm going to ask something very similar. You're going to have to know exactly how k-fold cross-validation proceeds as an algorithm. The second question here, another classic question, the one standard deviation rule. We've learned that, all right, once we try out dozens of different models, we could go with the model with the lowest estimated generalization error, but that's not a requirement. We're allowed to choose a different model, and the one standard deviation rule provides a guide for which models are acceptable. So, the one standard deviation rule says that two models are essentially equivalent when their estimated generalization errors are within one standard deviation of each other. So, all right, what does that mean? Where does that one standard deviation come from? What does it refer to? And how can you use that to narrow down the list of acceptable models and to rank models from essentially best to worst? Which ones are definitely better than each other? Which ones are equivalent? Knowing the ins and outs of that one standard deviation rule is something that I want you to know. And then also overfitting, that classic concept with predictive analytics, making a model too complex so that it's memorizing the quirks and the characteristics that are unique to that set of individuals that happen to be in the training data. That's essentially what we want to be avoiding. When a model becomes overfit, too complex, and basically memorizing the set of individuals it sees in the training data, it makes it powerless to generalize well, actually go and predict well on new individuals here. So there are a few plots, some things you want to review. This is a great demo that is you guys ran for your homework, the overfit demo, that shows that, okay, making models more complex isn't necessarily always the best thing to do. Yeah, it might help make the model fit the data in the training set better, fit the data that the model's actually using to estimate coefficients, etc., better and better. But on new data on the holdout sample, after a certain complexity, it starts to make worse predictions on new individuals. So it looks like in this case, the optimal complexity would be right at around 10 variables here. Be able to talk about this sort of plot here. Overfitting is something we definitely want to avoid in predictive analytics. Knowing what overfitting is, why it happens, how to avoid it, and to choose the optimal complexity of a model, something that I'm going to hold you to. This is another one of those key plots, and don't be too surprised to see something very much like it on the exam. So remember, each one of these dots represented a model. We had the estimated generalization error of this model versus the actual error on a holdout sample. And there were a few lessons that we learned. First of all, it looked like that the model building procedure tended to be overly optimistic on how well it was doing. The actual generalization errors tended to be a little bit higher than what the estimated generalization errors were. And then also we use this as a justification for the one standard deviation rule. The one with the lowest estimate here, all the way here on the left here, was not the one that ended up doing, the best on the holdout sample, illustrating that, hey, we don't necessarily have to feel compelled to use the one that had the lowest estimate. Key plot 3 we'll come back to at a later time here. No free lunch theorem we'll come back to at a later time here. Don't worry too much about that for right now. But here are some good slides. Estimating that generalization error with repeated k-fold cross-validation on the training data is important, and using that holdout sample as a final sanity check is an important thing. So here's that key picture illustrating fourfold cross-validation. Knowing the ins and outs of the procedure, definitely be very comfortable with that. One standard deviation rule, we covered that. That's good. We have a choice of models at the end. We can go with the one with the lowest estimated generalization error, or we can employ, say, Occam's razor. Go with the simplest acceptable model, or maybe the model that's the easiest to interpret, etc., etc. All right, so we talked about logistic regression, what you need to know about it. Well, be prepared to plug in values into the logistic regression equation. Know how to read our output, essentially. Know that R is predicting the probability of whichever class comes last alphabetically. and just be able to make a computation that looks like this. Only on your calculator instead of R. You're not going to be using your laptop here. How do we interpret coefficients? What do the numbers mean? What do the numbers don't mean? Well, make sure you're able to actually interpret the value of a numerical predictor, this right here, and make sure you're prepared to interpret the value of a coefficient of an indicator variable, something that's representing some level of a categorical variable. So there's some stuff about that. This is a little bit beyond where we're at right now. Don't worry about this slide, but this slide's pretty good too. When do we know logistic regression is appropriate? Well, this is the model underpinning logistic regression. So the probability of finding our class of interest, the one that ever comes last alphabetically, that are always be increasing with X or always decreasing with X for that model to be appropriate. All right, measuring a classifier's performance. This is the updated set of slides. So if in actuality the individual has the guess class, but we predict no, well, that's a false negative. We know how to calculate false negative rates, when they might be important, when the false positive rates are actually more important, etc. We've talked about examples of those. So based on a description, be able to identify what's a false positive, a false negative, and be able to make a judgment call over which one of the two errors are more serious. If either one is, maybe they're on equal footing, be able to be talking about that kind of stuff. So there's some examples. Not going to test you about kappa. Don't worry about kappa right now. We'll test you about accuracy though. Just 1 minus the misclassification rate, the fraction of predictions that are correct. And it'll of course also test you about the AUC. Very often in business analytics, we don't necessarily care for making classifications correctly because we're more interested in just isolating, say, the top 500 customers that are most likely to make this particular type of purchase. We don't care if our model predicts no for everyone. We just want to select those top 500 so that we can maybe market to them better. Maybe convince those people potentially in the future to buy. And we know that the AUC is a numerical measure that lets us know how well our model is ranking probabilities. So know to just an expert degree how to be able to interpret the value of an AUC. It's a number between 0 and 1. That's going to be on the exam, and I'm going to ask you to interpret it. Make sure you know how to do that, and make sure you know when the AUC is a more useful measure than, say, the misclassification rate. Remember, the AUC, very good if we care about the ranking of the probabilities, kind of picking out the top 500 customers that have a certain trait. All right, well, that's kind of my whirlwind review of what you want to be familiar with coming into the midterm. Let me go over last year's midterm extremely briefly, the stuff that I haven't gone over, just to let you know what you should concentrate on and what you can ignore for now. Question 1 is really, really good, and expect to see questions like it on this midterm as well. Question 2, overfitting. There's definitely going to be something on overfitting. I'm not going to talk about the no free lunch theorem on this exam, so don't worry about that. Question 4, talking about using that logistic regression to make classifications along with the naive model. Well, you can bet that's going to be on there. Interpreting the coefficients, plugging numbers in, calculating a posterior probability. Yeah, that's going to be there. D, E, F, and G, well, we haven't talked about that yet, so you can just skip. Don't have to worry about that. But we will be talking about that confusion matrix, calculating the misclassification rate, accuracy, false positive, false negative rates, and the accuracy misclassification rate of the naive model. Yeah, you're going to have to do that. Don't have to worry about rules of a tree. We're not there yet. But here we go, interpreting the value of an AUC, something you're going to want to know. Question 5, don't even look at yet. That's not going to be important. This J question right here, 100 different models have been considered. Which one do we actually end up picking? Well, maybe take a look at that one. All right, so question 5 we're skipping. Question 6, pretty useful. Logarithms, knowing how to unlog a quantity. Probably want to be familiar with that as well. And then finally, question 7 about code. You'll see something similar as well. So, all right, hopefully that was helpful to kind of narrow down the list of topics. And if you have specific questions, feel free to email myself or the TAs. Otherwise, bring your A game on Wednesday or Thursday. Bring your calculator, non-phone, non-laptop, and make sure you bring your sheet of notes. And best of luck studying.